The coffee cup moved first. Thomas Brennan noticed it during the morning shift change at the Riverside Machine Works, February 1883. He'd set his tin cup on the edge of his workbench, the same spot he'd placed it every morning for 3 years, and watched it slide. Not tip, not spill. Slide. 2 inches toward the west wall, leaving a dark trail of liquid across the scarred wood. He bent down to check the bench legs. Level. Solid. The kind of workbench that could survive decades of hammering, filing, and the weight of cast iron parts. He stood, pressed his boot against the floor planks, and felt something he'd never felt before. The floor was breathing. Not swaying like a suspension bridge, not bouncing like a sprung timber. It was tilting, so slowly, so subtly, that if you weren't paying attention, you'd miss it entirely. But Brennan was a machinist. His world was measured in thousandths of an inch, and the floor beneath him was wrong. Across the shop, Daniel Murray felt it too. He'd been turning a brass fitting on the lathe when his caliper slipped from the bench and clattered to the floor, rolling uphill. He stared at it, then at the floor, then at the caliper again. Metal doesn't lie. Gravity doesn't negotiate. Yet there it was, rolling away from the lowest point in the room. By noon, 6 men had reported the same thing to the shift foreman. William Hackett listened with the patience of a man who'd heard every complaint a factory floor could produce. Broken belts, seized bearings, smoke from the furnace room, but moving floors. He chalked it up to exhaustion, bad sleep, maybe too much drink the night before. Floors don't move, he said. Machines do. But the machines weren't moving. The steam engines, the lathes, the planers, the drill presses, every piece of equipment stood exactly where it had been bolted 18 months ago when the factory opened. It was the floor that had shifted, and as the afternoon wore on, more men felt it. The sound came next, a low hum that wasn't quite mechanical, wasn't quite structural. It lived somewhere between the whine of a leather drive belt and the groan of timber under load. It pulsed with the rhythm of the machines, but seemed to come from below, deep below, beneath the floorboards, beneath the joists, beneath the foundation itself. By evening, the rumors had started. Old buildings settle, the older workers said. New buildings stretch. But this wasn't settling. This was something else. Something that made tools slide, made footsteps echo strangely, made the air feel heavier near the center of the floor. Thomas Brennan stayed late that night, long after the steam was shut off and the machines went quiet. He walked the length of the workshop, dragging his boot heel along the floorboards, listening. In the silence, he could hear it more clearly. A faint creak, a whisper of movement, the building adjusting to something it couldn't quite bear. He looked up at the iron columns that held the ceiling, then down at the floor that held him. Somewhere between those 2 points, something was failing, and no one knew what it was. Riverside Machine Works wasn't built to last a century. It was built to open by spring. The company had secured a contract to manufacture railroad coupling parts, enough to keep 3 shifts running and 100 men employed. But they'd signed the deal in October, and the client wanted production by March. That left 5 months to design, construct, and equip an entire factory. So corners were cut, not maliciously, not recklessly, just quickly. The site chosen sat near the riverbank, close enough for water access but far enough to avoid flooding. The soil looked solid, packed clay over bedrock, or so the surveyor claimed after a single afternoon of test holes. No one dug deeper. No one questioned it. The foundation went in fast. Fieldstone walls 8 feet high, mortared with lime and sand, sunk 4 feet into the earth. Strong enough, they thought, for anything. The builder was a man named Josiah Venn, known for speed more than precision. He'd erected warehouses, grain silos, even a church. A factory was just another box with a roof. His crew worked through winter, laying joists over the stone foundation, bolting iron columns to the floor, then covering it all with 3-inch oak planks. Beneath those planks, out of sight, they used whatever timber was available. Some joists were white oak, some were pine. A few were salvaged beams from a dismantled mill, still bearing the scars of decades-old mortises and notches. No one checked whether those beams were sound. The walls went up next. brick on 3 sides, timber framing on the fourth to allow for future expansion. The roof was corrugated iron, pitched just enough to shed rain. Inside, the iron columns rose 16 feet to support the second-story gallery where lighter work, fitting, assembly, inspection, would take place. The columns were bolted directly into the floor joists, which were bolted to the stone foundation below. It should have worked. On paper, it was solid. But paper doesn't account for what you can't see. The soil beneath the foundation wasn't uniform. On the eastern side, the clay was dense and stable, compressed by centuries of slow geological pressure. On the western side, near the river, it was softer, layered with sand and silt, remnants of an old floodplain. When the weight of the building settled, it didn't settle evenly. The first cracks appeared within weeks, fine lines in the mortar of the foundation walls. Ven's crew patched them with fresh lime and moved on. The cracks returned. By the time the machines were installed, the foundation had shifted nearly an inch, not enough to notice from inside, but enough to stress the joists above. And then there was the wood. Some of the salvaged beams had been weakened by decades of moisture and insect damage. They looked solid from the outside, but inside the fibers had begun to crumble. When the weight of the machinery pressed down, lathes weighing 2 tons, planers at 3, the main steam engine at 5, the beams compressed. Slowly, unevenly, invisibly. The workers didn't know any of this. They arrived each morning, lit the boilers, engaged the drive shafts, and went to work. The floor felt solid. The walls looked straight. The machines ran true. But beneath it all, the building was adjusting. Joists sagging, columns twisting, foundation stones grinding against each other with every cycle of the steam engine. One of the older workers, a man named Samuel Croft, remembered hearing a sound 3 weeks before the floor started moving. He'd been working late, oiling the machines, when he heard a crack, sharp and sudden, like a tree branch snapping. He searched for the source but found nothing. The next morning he mentioned it to the foreman, who told him it was probably just the building settling. He wasn't wrong, but settling implies stability. What was happening at Riverside Machine Works was something else. The building wasn't finding its balance. It was losing it, slowly, incrementally, and no one realized until the floor began to move. It started with small things, things you could explain away if you wanted to. A machinist named Peter Dalton swore his lathe had moved overnight. He'd marked the position of the base with chalk, a habit he developed to track alignment drift, and when he arrived for the morning shift, the marks were off by half an inch. He checked the bolts. Tight. He checked the floor. Solid. He assumed someone had bumped it during cleanup and said nothing. 2 days later it happened again. This time 3/4 of an inch, still bolted, still tight, but shifted. The planers moved too. Heavy cast-iron machines weighing thousands of pounds bolted through the floor into the joists below, somehow migrating westward. Not all at once, not dramatically, just a slow, creeping drift that defied explanation. The foremen blamed the workers. The workers blamed the foremen. No one blamed the floor. Then came the carts. Riverside used wheeled hand carts to move raw stock and finished parts across the floor. They were simple things. Iron-rimmed wooden wheels on a steel axle, built to roll straight and stop when you wanted them to. But in the west section of the factory, near the river-facing wall, they didn't. You'd set a cart down, let go, and watch it roll backward. Not downhill, uphill. Slowly, almost imperceptibly, but unmistakably. At first, the workers joked about it. Haunted carts, magnetic floors, the ghost of the old mill. But jokes fade when the impossible keeps happening. Footsteps began to echo differently depending on where you stood. Near the center of the floor, your boots landed with a dull, solid thud. Near the western wall, the sound was higher-pitched, almost hollow, as though you were walking over a drum. Some men avoided that section entirely, uneasy with the way their own weight seemed to wake something beneath the boards. The hum changed too. During full production, when all the machines were running and the drive shafts were spinning, the building filled with sound. The chatter of metal on metal, the hiss of steam, the rhythmic thump of the main flywheel. But underneath it all, there was something else. A resonance. a vibration that didn't come from any single machine, but seemed to rise from the floor itself, as though the building were an instrument being played by forces no one could see. Thomas Brennan started keeping a journal. He noted the position of his tools each night and checked them each morning. Within a week, he documented 17 separate instances of movement. A file shifted 6 inches. A hammer turned 90 degrees. A box of rivets migrated from one bench to another. He showed the journal to the foreman, who dismissed it as paranoia. But Brennan wasn't alone. Daniel Murray rigged a test. He placed a steel ball bearing on his workbench and leveled it with a precision square. The next morning the ball had rolled. He repeated the test. Same result. He tried it on different benches, different sections of the floor. In some places the ball stayed put. In others it rolled westward, always westward. The workers began to speak in whispers. The floor is sinking. The foundation is cracked. The building is alive. None of them knew the truth, but they all felt it. The factory was changing shape, not collapsing, not breaking, just shifting, slowly, subtly, impossibly, as though the ground beneath them had decided it no longer wanted to stay still. By the end of the month, even the skeptics had to admit something was wrong. The question was whether anyone would believe them before it was too late. The truth wasn't supernatural, it was physics. Every machine in Riverside Machine Works vibrated. The lathes, the planers, the drill presses, the steam engine itself, they all produced oscillations as they worked. Most of the time, these vibrations were random, chaotic, absorbed harmlessly by the mass of the building. But occasionally, under the right conditions, they synchronized. It's called harmonic resonance, and it happens when multiple vibrating systems find the same frequency. A platoon of soldiers can collapse a bridge by marching in step. A singer can shatter a glass by hitting the right note. And a factory full of machines, each spinning at slightly different speeds, can align just long enough to amplify their collective force. When that happened at Riverside, the entire floor began to oscillate, not violently, but persistently. Like a tuning fork struck too softly to hear, but strong enough to feel. The foundation made it worse. Because the soil beneath the western side was softer, the building didn't rest on uniform support. The eastern columns stood firm. The western columns sank, just millimeters at a time, but enough to tilt the floor. The tilt changed how weight distributed across the joists. The joists flexed. The flex created stress points, and those stress points vibrated differently than the stable sections, creating a feedback loop that amplified the movement. Then there was the iron. The columns holding up the second-story gallery were cast iron, strong, rigid, and highly responsive to temperature. During the day, as the forges and boilers heated the factory, the columns expanded. At night, they contracted. The expansion pushed the floor upward, fractions of an inch, but enough to shift the load distribution. The contraction pulled it back down, but not always to the same position. Over weeks, this thermal cycling created a ratcheting effect. Each expansion pushing the floor slightly westward, each contraction failing to pull it fully back. Beneath the floorboards, one of the main support beams had split. It had probably cracked during the initial construction, hidden by the planking, unnoticed until the weight of the machines pressed down. The split allowed the beam to act like a hinge, flexing under load instead of holding firm. Every time the machines ran, the beam bent. Every time they stopped, it rebounded. The workers felt this as a rising and sinking sensation, as though the floor were breathing. The vibrations scored the wood. If you pulled up the planks, you'd have seen it, fine grooves worn into the joists where the floorboards had rubbed back and forth thousands of times, microscopic movements adding up to visible wear. The friction created heat. The heat dried the wood. The dried wood cracked, and the cracks allowed even more flex. The carts rolling uphill weren't defying gravity. They were responding to the floor's subtle tilt, which changed throughout the day as the foundation settled and the columns expanded. What looked like uphill in the morning was actually downhill by afternoon. The workers' perception of level had been shaped by the static floor they expected, not the dynamic floor they were standing on. The hollow sound near the western wall wasn't a ghost. It was the gap that had formed between the floorboards and the joists below. The settling foundation had pulled the joists downward, creating an air space. When you walked over it, the boards flexed more than they should, and the sound reflected back differently. You were hearing the absence of support. And the hum, the low, persistent vibration that seemed to come from everywhere and nowhere, was the resonance of the entire structure. The floor, the columns, the joists, the foundation stones, all vibrating at frequencies just below the threshold of conscious hearing, but well within the range of physical sensation. You couldn't hear it as a sound, but you could feel it as a presence. The factory wasn't alive, but it was moving, and it had been moving since the day it opened. The workers had only just started to notice. It happened during the third shift on March 14th, 1883. A Wednesday, cold, clear, and quiet outside. Inside, 32 men working under lamplight, the machines running at half speed for maintenance work. Thomas Brennan was at his lathe, turning down a brass valve housing, when he felt the floor drop. Not settle, drop. A sudden, sickening lurch like missing a step on a staircase. The lathe shuddered. The drive belt slapped loose from its pulley. Across the room, a grinding wheel spun free from its arbor and skittered across the floor, trailing sparks. Men shouted. Someone killed the steam. For a moment, everything went silent, except for the hiss of pressure bleeding from the pipes. Then came the sound. A crack not sharp like breaking wood, but deep and resonant, like stone grinding against stone. It came from beneath the floor, somewhere near the center of the room, and it spread outward in a wave. The floorboards buckled, not collapsed, not splintered, but buckled, rising in one section, sinking in another, the oak planks bending like a warped deck. Peter Dalton's lathe tipped. 2,000 pounds of cast iron, bolted through 3-inch planks into the joists below, tilted backward and slammed into the machine behind it. The impact sheared the bolts. The lathe skidded westward, its base scraping across the floor until it collided with a workbench and stopped. Tools slid, carts rolled. A stack of iron bar stock toppled and clanged across the floor like church bells. The men scrambled toward the doors, boots pounding on boards that no longer felt solid. Some grabbed their coats, some didn't. No one looked back. Daniel Murray was the last one out. He stood in the doorway holding a lantern, watching the floor move. It wasn't violent, it wasn't fast, but it was undeniable. The western section had sunk 3 inches, maybe 4, creating a visible slope from east to west. The iron columns had tilted. The joists had sagged. And beneath it all, through the gaps in the floorboards, he could see the foundation stones shifting, grinding against each other, glowing faintly in the lantern light with decades of accumulated dust. The building groaned, not the creak of old wood, but the groan of structure under stress, every joint and connection protesting the forces it was never designed to bear. Murray backed away and let the door swing shut. By morning, the damage was clear. The western third of the floor had dropped 4.5 inches. 2 of the iron columns had bent. The main drive shaft was out of alignment. 3 lathes, 2 planers, and a milling machine had shifted enough to render them inoperable. The forges were intact, but their chimneys had cracked. And beneath the floorboards, the foundation had settled unevenly, leaving gaps where there should have been solid support. No one was hurt. That was the miracle. If it had happened during the day shift, with 100 men on the floor, it would have been catastrophic. But the third shift was small, and the men had been paying attention. They'd felt the building warning them for weeks. When it finally gave way, they were ready. The factory stayed closed. Engineers were summoned. Investigations began. And Thomas Brennan, standing outside in the cold morning air, stared at the building he'd worked in for nearly 2 years and wondered how something so solid could betray you so completely. The engineers arrived with notebooks, plumb lines, and an air of professional skepticism. Factories didn't just sink, not modern ones, not ones built with iron and stone and oak. But when they stepped inside Riverside Machine Works, the skepticism faded. The floor told the story. From the eastern wall to the center of the room, the boards were level, or close enough. But past the center line, the slope was unmistakable. They measured it with a transit and confirmed what the workers already knew. a 4-inch drop over 30 feet, the kind of settlement that takes decades in a well-built structure. Here, it had happened in 18 months. They pulled up the floorboards near the western wall and found the first clue. A support beam split lengthwise, the fracture running 8 feet along its core. The wood was oak, but old oak, salvaged, they guessed, from another structure. The split had likely existed before installation, hidden by the intact outer surface. Under load, the crack had opened, allowing the beam to compress unevenly. The joists it supported had sagged. The floor above had followed. Deeper inspection revealed more. Beneath the split beam, the foundation stones had shifted. The mortar between them had crumbled, leaving gaps where there should have been solid joints. The soil beneath was softer than expected, sand and silt instead of clay, compressed but not consolidated. When the weight of the machinery pressed down, the soil compressed further, unevenly, creating differential settlement. The eastern side of the building stood firm on bedrock. The western side sank into unstable ground. The iron columns showed stress marks. Fine cracks radiated from the bolt holes where the columns attached to the floor. The thermal expansion had done its work, each heating cycle pushing the floor, each cooling cycle failing to return it. Over months, the cumulative effect was measurable. 3/8 of an inch westward, pressed into the joists, warping the structure. They found vibrations scoring on the joists, parallel grooves worn into the wood by the constant back-and-forth movement of the floorboards above. The scoring was deepest near the center of the room, where the harmonic resonance of the machines was strongest. Some joists showed signs of heat damage. The wood darkened and dried from friction. One joist had worn so thin it had nearly severed. The foundation walls told their own story. On the eastern side, the mortar was intact, the stones seated firmly. On the western side, the mortar had fractured in dozens of places, and the stones had rotated slightly, grinding against each other. The rotation had created instability, which amplified the settlement, which increased the rotation, a slow mechanical spiral that ended with the floor sinking and the building tilting. The soil samples confirmed it. The engineers dug test holes around the perimeter and found what the original surveyor had missed. The western side of the site sat on an old riverbed, layers of sand and gravel deposited centuries ago when the river ran higher. It looked solid on the surface, but under sustained load, it behaved like a liquid, compressing and shifting. The building hadn't been anchored to bedrock. It had been placed on sand. The final discovery came when they removed a section of flooring near the main steam engine. Beneath the boards, they found a gap, a void where the joists no longer made contact with the foundation below. The settlement had been so uneven that parts of the floor were now suspended, held up only by the rigidity of the planking and the lateral support of the walls. The workers had been standing on a surface that was, in some places, floating. The engineers compiled their report with a mixture of professional detachment and quiet astonishment. Every failure they documented was predictable individually: soft soil, salvaged timber, thermal expansion, harmonic resonance, uneven loading. Any one of these could have been managed, but together, compounded over months of operation, they'd created a cascading failure that no one had anticipated. The foreman read the report and asked the only question that mattered: can it be fixed? The engineers looked at each other, then they looked at the floor. Yes, they said, but it'll be easier to build a new one. Riverside Machine Works never reopened. The company relocated to a new facility on higher ground, built on bedrock, with deep pilings and engineered foundations. The old factory stood empty for 2 years before being dismantled. The iron was sold for scrap. The oak was salvaged for other projects. The stone foundation was left in place, slowly sinking into the soft soil, a monument to ambition and haste. The workers moved on. Thomas Brennan found employment at a textile mill where the floors were concrete and the machines were bolted to steel frames. He never forgot the sensation of standing on a surface that moved beneath him, the feeling that the ground itself was unreliable. It changed the way he walked through buildings, always testing, always listening. Daniel Murray became a mechanical inspector, traveling from factory to factory, checking foundations, measuring tolerances, searching for the early signs of failure. He carried a level and a notebook, and whenever he found a flaw that didn't sit quite right, he'd mark it, document it, and recommend reinforcement. Some companies listened, some didn't. The lesson of Riverside was simple, but not easy. The Industrial Revolution built faster than it understood. Factories rose in months, filled with machines that produced forces the buildings were never designed to contain. Engineers learned through failure, floors that sank, walls that cracked, roofs that collapsed. Each disaster taught them something new about loads, vibrations, materials, and soil. The ground beneath a factory is never just ground. It's geology, hydrology, compression, and time. It's the memory of rivers that moved centuries ago, the weight of ice that pressed down millennia before that, the slow transformation of rock into soil into sand. You can't see it from the surface. You can't measure it with a surveyor's chain. You only learn it when the building starts to move. The machines don't lie. They vibrate at the frequencies their parts produce. They press down with the weight they were built to carry. They heat the air, expand the iron, and transfer their motion into everything they touch. If the structure beneath them is sound, the forces dissipate. If it's not, they amplify. Slowly, persistently, until the day the floor shifts and everyone realizes the building was never as solid as it seemed. The workers at Riverside knew. They felt it before the engineers measured it, before the foreman believed it, before the floor finally gave way. They knew because they lived on that surface, hour after hour, day after day, their bodies attuned to vibrations and sounds and subtle shifts that instruments couldn't yet detect. They were the first sensors, the earliest warning system, and they were right. The industrial age built with confidence and speed, but it learned with humility and time. Every factory that sank, every floor that moved, every foundation that failed, they all added to the collective knowledge of what it means to build something that lasts. Not just strong, not just fast, but stable, rooted, trusted. The workshop floor that wouldn't stay still taught them that, not through theory, not through blueprints, but through the undeniable reality of men standing on a surface that moved, feeling the ground shift beneath their feet, and knowing that something fundamental was wrong. The building is gone now, the machines are scattered, the workers are dust. But the lesson remains, written into every modern code, every foundation specification, every load calculation. The ground beneath you matters, and if you don't understand it, it will move. Slowly, quietly, inevitably. Until the day you notice your coffee cup sliding across the bench. And by then, it's already too late.